Right. So chapter 2, we're going to start talking about graphical summaries. So this is where we're going to start making a lot of different graphs. And we're going to look at qualitative data, and then we're going to look at quantitative data. And we're also at some point going to look at like ways that we use graphs to mislead. We're going to start with the qualitative. So we're going to start with what they called a frequency distribution. And frequency distributions are not solely for qualitative data, they are for quantitative as well, but we're just doing the qualitative part right now. So the frequency of a category is the number of times that it occurs in the data set. So if you collected a data set asking, like, what's your favorite animal? Is it a cat or a dog? And like 5 people say it's a cat, then the frequency would be 5. Frequency distribution is a table or chart that represents the frequency of each category. So, you'd have how many people said cat, how many people said dog, how many people said they had a rabbit, those kind of things. So, see if I can get this to fit in here a little nicer. So, a retailer accepts 4 types of credit cards and lists the types used by its last 50 customers. So we go through here, and if you were to organize this data, what you'd do is you'd make a chart. And what you'd have is you'd have the card type, a credit card. A little bit. We're not quite yet, but we're usually going to refer to this as the X. So this is going to be what is our variable that is changing from person to person. The credit card they're using changes. And then over here we'd have frequency. Been just right, but enough. Credit cards you see is that some people have a Discover card. Some people have a Visa. We have American Express. Let me see. Can I miss something in here? MasterCard, so just say MC MasterCard. Okay. 4 types of cards. Right down there. So all we do is we just go and see how many we had of each one. So if we look at Discover, we got 1 here, 2, 3, 4, 5, 6, 7. You see that frequency would be 7. We'll go through and count our Visa cards. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 Visa and American Express. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I count these Visas over here? I guess we'll see here in a second. And then our MasterCards, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I think I missed these. So 1, 2, 3, 4, 5, 6, 7. So I think it's 23. I think I miscounted somewhere. One of the things to do to check if you miscounted is that they should have 50 customers. So the 7 plus the 23 plus the 9 plus the 10 should equal 50. So I definitely miscounted one of these. Not sure what it was. We'll go to the next slide to see what it should have been. It was my visas. I miscounted the visas. I think maybe I counted some twice. So if we went back, so there should have been 11 MasterCards. Yeah, I was missing. So I miscounted the MasterCards. The Visa I had right, the American Express, and Discover. So I just miscounted one of them. Like I said, that's always a good way to check. Like this, I can tell was like It was 49. It wasn't quite there. I knew I was missing something. But yeah, always check your frequency. So the frequency here should add to 50 because we said we had 50 customers we're looking at. Your frequency should always match the amount of people we were sampling. That's really all a frequency distribution is. We don't necessarily put this in any particular order in a frequency distribution. When it's qualitative data, we leave it like this. I just want to make this point that with qualitative data, there is no particular order. To the variable. In this case, credit card. If it had been like hair color, we wouldn't have a particular order for hair color either. So we have these variables that don't necessarily have an order to them. We don't really worry about ordering them. So we also have relative frequency, and relative frequency is really telling us a proportion. So a frequency distribution displays how many observations we have in each category. So we had like 23 American Express cards, right? Visas. We had 23 Visa cards. We just have a number for that. Sometimes we're interested in the proportion of observations in each category. Sometimes we're interested in the proportion of each category. So the proportion of observations in a category is called your relative frequency. And the relative frequency is just your frequency divided by the sum of all your frequencies. So in our case, if we're talking about those Visa cards, we had 23 of them. We know total cards. Out of all of the people came in, we had a total of 50. So the relative frequency would end up being the 23 over 50. So we write like that, or you can write the decimal version of it. So almost half of them, so 0.46, so about 46%. So in statistics, we have a tendency not to think about percent though. If we added up all the cards, we should have 50 of them. So MasterCards were 11 out of 50. So the relative frequency is 0.22. Or what we know that to be is 22%. Visa was here. I don't know why that's coming in together. We said 22%. So Visa card, that's 23 out of 50, where oh, that's 0.46. Well, 46% of the people came in with a Visa card, 9 out of 50. So about 18% came in with a American Express. 7 out of 50 is 0.14. So about 14% of people came in with a Discovery. So typically, when we talk about relative frequency, even though we know it is talking about a percentage, we write those frequencies as decimals or fractions. So you almost never are going to see it as percentages. When you present data to the layman, to the rest of the world, um, to just your average people, then you usually use those percents. If you're actually reading a study that was meant for a particular field, like if you were looking at medical journals or something like that, they would not say percents. They would use these relative frequencies as decimals. Okay, so just out of practice, take a moment of this one and make a frequency distribution. So the following list the types of aircraft for the landings that occurred during the day at a small airport. So we have aircraft types. I don't really know that much about aircraft types, but we got a twin, a turboprop, a jet, a helicopter, a single. So I can think it's a twin engine and single engine. I think that's what it was saying there. Now looking at it, but go through those. And so you're just going to make a frequency distribution and then figure out what is actually your frequency. What is the frequency of each of just the single engine category? Hopefully we're going to get the same answer here. So if I count my twins, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like I have 9 twin engines. If I count the turboprop, we have 1, 2, 3, 4, 5. The jets, we have 1, 2, 3, 4. This is 4. We'll see here. We'll double check this in a minute. Helicopters, looks like 1 helicopter, 2 helicopters. And then the single engines, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if I have this up, I'm going to have 6, 7, 8, 9, 10. Okay, so actually I'm going to go through it again. 14, 15, 16, 17, 18, 19, 20. So we should have 30 all here. If we count this 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yep, that's 30 of them. We got them all. Our frequency distribution. So what's the frequency for single? 10. We have 10 of them. So we're going to ask this question again. So I'm going to erase some of this so I can keep part of this chart. So what is the relative frequencies now? So we already got the frequency. We know there's 30 of them. So if we talk about relative frequency, so just to point out here, so when I was talking about aircraft, use X for aircraft, use F for frequency. When I do relative frequency, we don't have F, we have divided by N. If you remember, N represents your sample size. So it's how many items I have. So if I do that, we have 9 out of 30. So I need to get my calculator going here. It's just slow. 9 out of 30, so that is 0.3. This is where I'm really going to need it here in a minute. If we do 5 out of 30, well, that relative frequency is just 0.16 repeating, so I'm going to say 17. We're just going to round it to places. The 4 out of 30 is going to be a 0.13 repeating, so I'm going to say 13. These ones are estimations. Then the 2 out of 30, that's 1 out of 15. Then that's going to be 0.06 repeating. That makes it 7. And then when we do the 10, that is a third, so that is going to be 0.3 repeating. So say 33. Okay. If you add up your relative frequencies, they should be approximately 1. I think when I add these ones up, they are going to be 1. Plus the 17 plus 13 plus the 7. Yep. So this one does equal to 1. So relative frequency should always equal 1. These are just ways to check and make sure you did everything correctly. Rounding, sometimes it's going to be not exactly 1, but it should be pretty close to it if you did everything right. We constructed the relative frequency distribution. So what we need is the relative frequency of single. So that would be, got my out of 30s here. That's a little important. It would be 10 out of 30, or we would say 0.33, about 33%. What other way saying it's a third of them. Okay. I just want to mention this again. So frequency and relative frequency distributions can be used to organize and display qualitative data and quantitative data. We're focusing just on the qualitative here, but in the next section, we're going to do quantitative. So there's some slight changes to quantitative. And one of them is being with quantitative, because you're dealing with numbers instead of just categories, that data is going to be organized from smallest to largest, where here we don't necessarily organize it in any particular way.